Good evening and thank you all for joining us today. I am Partharu, event planner at Microsoft Reactor Bangalore. This session will run over next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, be kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker and co-founder at TechScalable. Being passionate about ever evolving technology, he works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. Over to Shivam to begin the session.
Thank you, Parth. I'll share my screen. Okay, so welcome everyone. Hopefully all of you are doing well, you're safe, and let's get started. So before we jump into the details, I will just walk you through the learning module. And if you go to the meetup page, today we are going to cover, today is the fun session, and we are going to talk about the use cases, the other use cases which we do not very you can say which we do not come across very often as such, but machine learning has incredible use cases in different domains. And one of the use case which will be in the domain of space exploration, where the rocket delays are predicted using machine learning. So we will be understanding what are the various challenges which are faced by when these rockets are launched, and we have one data set with us and we will do analysis of that data set. Now, I will just walk you through the learning module before that. So if you go to the meetup page, you will find the link in the bottom of the page over here. And if you go to that particular MS Learn link, you will find that whatever we are going to discuss will be there on that meetup page as well, on this MS Learn page over here. And this MS Learn page is having three sections: introduction to rocket launches, data collection and manipulation, and building a machine learning model. So whatever we are going to discuss will be taken from, or will be is already documented there for you to complete after the this session. So if I click on one of them, you can log in from the top. You can use the sign in option. You can use any email ID to sign in. You can also save your progress by doing that, and you can simply go through this step by step, step one, and so on and so forth. So the learning module is there on the meetup page, which can be done after the session. And I'll just put this in the chat window as well for you to bookmark if you want that. So it's in the chat as well. Now let's get started. So before we jump into the code, so today is a different type of session. It's not the usual deep learning session which we do, or any other type of session which we usually do. So we are going to understand some few problem statements as such. We have various. I have kept various websites open with me. I'll walk you through the various websites and so on and so forth. And let's get started. Check this out. So we are talking about the delays, or think about any rocket launch, right? Even before we think about the delays, the it takes years and years for planning the launch of the rockets. And these rockets have, it's just not about the rocket which is getting launched. It also having, it must be carrying some sort of scientific instruments on board. It might be carrying any satellite on board. It might be carrying any other type of payload which might be very expensive, might be very critical for a country or for the community or for the scientific community as such. Takes years and years to plan for these, to build it up, to research. A lot of things which are launched by the rockets are the first times, they're built for the first time itself. And there are few, you can say, as per NASA, there are few guidelines which they follow. The guidelines are that whenever any launch is being done, the area, it's better to do the launch over open ocean, or if, because in case if there is something goes wrong, then the failed rocket may drop in the ocean as such, and not on any land over there. So uh, they also take care that nothing should disrupt the trajectory of the rocket as such. And the rocket is launched from near equator, so it takes less distance to reach the outer space. And it's safer to do this over a large body of water for obvious reasons, and do it from equator, as close as possible from equator. So they have their own launch sites. Similarly, ISRO in India also is having its launched site near the ocean body over there. And you will notice that, thinking of the payloads which it is carrying. So here I have the image of James Webb telescope. And this image is from 2016, when the telescope was assembled for the first time. The complete telescope was assembled on Earth for the first time, and this and just and this is the history of James Webb Telescope. You might be aware of it, right? It was a telescope which was launched a few years back, and it has already reached the location called as L2 point, and then it will be taking the images of faraway galaxies for us, and it is better than Hubble, and it is supposed to outperform Hubble. Now, if you check out the I have copied this from Wikipedia. So the launch, or let me just zoom in. Let me see if I can zoom in a little more. Okay, so in 1996, the initiation was done for that telescope. The name was different, so you can think that behind that rocket launch, which took this up, that process started in 1996 itself, and then multiple times, and the name was changed after a few years in 2002. Then there were some problems. Handoff was done. Cancellation was attempted over there in 2011. Then funding got hit in 2014. So you can think that it's very that how critical was this, that the scientific community was taking care of this from such a long time. And in December 2021, the final launch was done, and it was successful. And it's one of the and it's already, these are the 18 mirrors which are there, which will be taking the images of the faraway galaxies for us. And this is that, just FYI, this is that point where it is right now. Already reached this L2 point, Lagrange point, and there the telescope is right now in this point in time as we are speaking. The 18 mirrors are getting aligned, or the calibration is going on, which will go on for 6 months. I'm not sure how many months have already been passed over there, but it was supposed to go on for 6 months. And finally, it will start taking images for us. So this is where that L2 point is there. So there is a huge, you can say, there is a huge uh, uh, timeline behind just one of this space launch, which was very critical for solving the mysteries of the universe, and it all depended on the rocket launch. So the this particular spacecraft, this particular lens was so big that it was not possible to take it the way it is, and they already they had it in the biggest the rocket which was used for the launch was one of the biggest one, but still uh, it was not possible to take the entire lens in one frame, or you can say the combined lens was not possible to put it over there. So they broke it into these smaller pieces, not broke it, they made it in this manner, and then it will reassemble into the golden color image which we were saying some time back, right over there. So the rocket launches are very important. They have huge uh, monetary funding done for them, and they are very important for various use cases. Now, anything can things can go very wrong when we talk about rocket launches. because of humidity, hurricanes, tornadoes, rainstorm. These are some of the factors which can concern the rocket launch. And if you practically think it through, it's so difficult uh, to predict the weather. Like if you think of your local weather station itself, wherever you are joining in from, if you think about the weather, it changes very frequently. There might be very less space. You can say locations on the planet Earth where the weather remains constant for a very long time. Sometimes the the cloudy weather is there, then sunlight comes out, and then so on and so forth. There is a very frequent change. The problem is, from the point of view of logistics, from the point of view of any mission which needs to be launched, NASA or any other space agency needs to predict about the day in the year where the launch can be done. Uh, you can say years ahead in time. For example, many years ahead of time, they will find those days on which the weather is likely to be the best weather, or the weather there is no. It's not likely that the that any condition will not be there which can push the launch. It may have other impacts. Recently, just I think a few weeks back, there was a lightning strike which happened on the SpaceX rocket, I think, and but it was called to be safe. I didn't follow it after that. Maybe it got launched or not. Maybe yet to be launched. But things like that happen. So weather changes very fast. It's very difficult to predict the weather ahead of time. So this is where machine learning can help us out. This is where data analysis can help us out. And even with data analysis, then even after that also, the prediction of the weather is something which is very difficult. And the you can say month by month weather or hour by hour, week by week, hour by hour, minute by minute, whether uh, the weather related information is gathered and the call is made on top of it, that whether this launch is a go or not. So I think I'll just take you to, before I go into the machine learning part of it, I will just take you to the few of the pages which I have kept open for you. Now notice this. So if you think about, so that this is one of the graphic which I opened, and it's part of your learning module only. If you go to the learning module, you will find it over there. So this is from 45th Space Wing. It's a part of uh, you can say the US military, which supports the space launches. And I will just scroll down to the things which I want to show you. You can find this graphics in this PDF in the learning module. Now check this out. So as per this document, which or as per the agency, there are 10 rules that are designed to avoid any natural and rocket triggered lightning strike to in-flight rockets. And the launch, so this will happen in real time, right? You can say they will predict it, but still the data will be gathered in real time as well to make the final call, or to make the final decision on top of it. So you will see that the launch officer, the launch weather officer, must be clear and convinced uh, that none of these criterias are violated in order to give the whether go call for the launch. So the criterias are based on these high level classification here. So the surface electric field rule is there. Surface electric field rule is depending on I googled for it. So it depends on the charge, the surface charges. The lightning rule, lightning should not be there. We have the cloud rule. The this type of cloud should not be there. Anvil shaped cloud with lightning, or the this type of clouds. It must be very difficult for them to understand whether this is an anvil based cloud and the lightning is happening, maybe or how much, or this cloud where one portion is broken off seems to be moving ahead versus the other ones. So these are the conditions which are not good for the, you can say, which are not good for the launch. The disturbed weather and the thick cloud is there, and smoke because of any fire, and Tribo electrification rule. This one I just kept it open for you over here. You must be remembering it. You remember that if you take a party balloon, if you rub it any woolen cloth on top of it, and then it becomes charged, and you can stick it to various surfaces. This is that one, similar to that. Not I'm not an expert in this. You can go and further read this, but this is something in that direction, right? So the tribo electrification rule. So the surface when it leaves when it goes away from the contact of another surface, it may get charged. And these rockets are highly conductive. These rockets are they have so much. They also will be having liquid fuel over there, or maybe solid fuel over there. So it's highly flammable as well. So if something goes wrong, it can be life threatening. So these rules are there. And apart from that, there is another classification here that that because of the rocket launch, if it creates any type of lightning that is life threatening, so which may be possible because of it can trigger the lightning because of the exhaust fumes or the exhaust gases which are coming from it. So all these things needs to be avoided, right? So these are the rules which we will be avoiding. So the data which we are working with, it has been gathered by from various locations. I will just open few of the websites first. So this website is of National Oceanic and Atmospheric Administration, US Departments of Commerce. And if you go to their website, a part of the data, weather data, is gathered from here. They NASA also collects data from them. And if you can just go and have a look at this website. It is having a few of very interesting data sets over here. Their satellite data set research will be there. You can also look at some other options here that I think over here the data about the methane level, data about the sea levels which are changing throughout time, and from this website. Or you can also go and have a look at the data of regarding other things as well, oil spills and so on and so forth, and about fisheries, about satellites, about the satellites which are gathering data for various purposes over here. And right, okay. Now apart from this, uh, NASA also have multiple different you can say sources from where they gather data. And one of the source from where they gather data is they launch these scientific balloons. And these scientific balloons are and they have the scientific payload over there. And these scientific balloons, they gather the data. And there are a few classification of these balloons. You can, when you get time, you can go through the learning module and you can read further about it. Like zero pressure balloons are there, super pressure balloons are there, the amount of scientific instruments that can be carried because of that. So data is getting gathered from these locations, 2700, 2721 kilo as such. And some planetary balloons are there. These are not in this regards. This like what happens if you if you fly the balloon in on Mars. So you can say these types will be here on the top. They also gather the data. This is more like an IoT scenario where these devices are gathering the data, and based on that, the weather, the predictions are being done. Now, if I show you a couple of more things, there are a few balloon sites from where NASA launches these balloons. There are a few missions also which are listed on one of the page. You can find it, which are right now active. And apart from this, if I show you, this is another location from where NASA gathers the data. The data is gathered from the satellite feed. So this is satellite feed right now. And this will be, you can say there are various the full disk, half disk, full disk, and specific geographic location based feeds are there. So if we open one of them, we will be able to see that the data, this type of data is there. You can extract this data. It will be, it's 20th April. It's today's data. It was 12:30 UTC is when it was updated last time. And it's showing the cold, the altitude, and the all the how warm it is over there, because everything will affect your weather. The cold, the difference between the cold and the hot temperature, and the movement of the air will start happening because of that. So all of that will be affecting the temperature as well. So they gather data from from the satellite feed as well, like this. Now, which you can also use for your own analysis. You can go to these websites and you can get the data from there. Now, they also have these remote sensors. NASA gather data from them. There are two type of remote sensors, passive and active sensors. Active sensors, they have their own energy source. They send the radiation, and the one which is reflected, they measure the difference between that. And the passive ones, basically, they detect the light which is coming from sun and from any other luminous source, and it understands it detects various sources. It detects the temperature and different the matrices based on the other luminous source energy. You can say light which was reflected. So these sensors are there from which NASA also gather information, and there are few of the platforms and current missions which are going on, based on which the data is being collected. So the radar and the lidar over there, and various other things are there. Aircraft based missions are going on, and so on and so forth. So apart from this, this is another website from where the data has been gathered for today's example as well. National Data Center for Environmental Information, and their website is under maintenance in today, but you can come to it after 21st 04, and you can download the climate data, monitoring data, and so on and so forth from here, the oceanographic weather data from this, and the data from NASA's own website can be downloaded from this link, data.nasa.gov, and you can go to these archives. I may have opened few of the interesting ones here. So the archives are there. You can get the data for various future uh, experimentation. If you want to learn machine learning, and if you're thinking of how to stay motivated, pick up any of the data set which can be which might motivate you more to stick with machine learning, because it takes time to learn it. It will not be you won't be able to do this in few months. It will take you maybe 8 to 18 months to do that properly, to get started with it. So pick up these interesting data sets. We have Mars orbital data sets, and the something else over there, um, as such, and another data sets for different purposes can be picked up from there. So all these links are available in the learning module over there. Now, if I take you to that's the developer resource, you can use the APIs. The API documentation is also available over here. How will you pull the data from NASA's website? You need the key, you need to do registration, but once you have done it, you'll be able to pull the data from there. Okay, now this is another location from where today's data has been gathered from the underground. This is historical weather information data has been gathered from there, and these are the list of the NASA missions which we have all here. Now, where where you can see Mercury program, Gemini, uh, the space, the International Space Station, Apollo, number of Apollo missions were there. So I'll take you to my data set now. So if you think about machine learning, right? Before I go take you to the data set, if you think about machine learning, we have these four major steps over there, or four steps are there, and in which the business first you need to know why you're doing it, uh, the business reason behind it, the reason behind the experimentation for which you have to gather the data. It should be very clear between the data scientist and the business owners as well, of the various stakeholders, like what's the purpose of what we are doing. This is where the difference happens between any other uh, application development versus machine learning project. It's possible that once you gather the data for that business purpose, you will analyze, and during the EDA phase, exploratory data analytical phase, you will realize that it is not possible to achieve the business goal from this data which is there, and it's the end of it. So it may never go beyond that point. So the business understanding first, then we need to gather the data. Let me zoom in for everybody. So I'll see if I can zoom in a little bit over here. Okay, okay. So the data needs to be gathered from various sources. Now, the sources which we talked about for the space station is something which is not really in our hand. We need to really go to these websites and get it from the public's point of view. And definitely any private contractor's point of view, that they can, maybe they have more connects, but you can get the data just generally. We can get the data from in batch mode stream. We can have environments in the cloud, on-prem database, data lakes can be there, structured, unstructured data might be there, the images of this of the clouds to see whether that cloud is anvil shaped or not, right? Deployment will be done, the modeling, and all these phases will be interchanging. You can say we can go from one phase to another phase. So this is representing the, this is not really representing MLOps pipeline, but MLOps pipeline will be done after this. And where the feature engineering over here, transformation, binning, algorithm selection, and so on and so forth happens. So the very first thing is business goal. So the in the problem statement that we have today, the business goal will be something like uh, that we have to find the number of days on which the rocket can be launched, and it doesn't have uh, and that doesn't happen, right? That should not happen. This image is not really because of weather loss, sorry, weather issues. This image has been taken from it's a Japanese rocket which end up doing that. So but things can go wrong. So now, from NASA's point of view, they have SMEs, and these SMEs will be physicists. They will be meteorologists over there, biologists, and rocket scientists, and many other subject matter experts who will determine what are the factors which are responsible for a good launch, or for what are the sources which are critical uh, for 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 the good launch, and for the launch itself. Good launch may be considered later on. So then once these SMEs, and they will describe the sources, then we start gathering the data from these sources, from all the IoT devices, and so on and so forth. Uh, Now, the another important thing which comes over there will be regarding the algorithm which we have to select. Now, before I go in the algorithm, I want to show the data first. I am just thinking of one image which I wanted to show you, and let me see where it went. Okay. Okay, yeah, sorry. So yeah, these are the business problem statements which I have written over here. This image was supposed to be before that. Now the business statement also, the goal, the goal for the experiment is: will weather condition on a specific day support a successful rocket launch, or or what day in X number of years will be least likely to require a launch push due to the weather as such. So these are few of the statements for which we can do the uh, we can train the ML model for. So keeping these statements in mind, so will the weather condition on a specific day support the successful launch or not? Yes or no? Or which day in X number of years will be useful for that? So yes or no type of. So if I show you my data set, which is over here, you will, or let me open the Excel one. Let me just don't scroll that much over there. We'll come back to this algorithm and selection. Let me go to the data set. I have it open in the Excel right now. So you will see that on the left-hand side, we have all these missions over here. Pioneer 3, Pioneer 4, which I was showing you on the Wikipedia page. Uh, Ranger 1, Ranger 2, Ranger 3, and so on and so forth. Over there, deep space, and so on and so forth. Now, there are other dates as well on the date it was launched. So you see, launch, yes, launch was done on that particular date as such. And the and whether there was a crew or whether there was no crew, that information we have. The location from where the launch was done. So this is the prominent location for NASA to do the launch, because it is near the ocean body, and the temperature, the weather conditions are relatively stable there. And what was the temperature on that day? High temperature, average temperature, what was average precipitation value, wind direction as such on that day, and then the maximum wind that was observed, visibility which was there, and the sea level pressure as well. And all this data is factual data. This has been gathered from their website. Now you will notice that the launch happened for this observation. Sorry. Uh, right? And the condition was cloudy over there. So it's not always uh, see different type of payloads, different type of rockets. They have different requirements. Different weights are also there inside the payload. They have different requirements. It's not that if it is cloudy, it's never done, right? It's not like that. That if there is no light on the launch pad, then it's not done. It's not like that. There, the SMEs and the various factors are taken into consideration for deciding whether it's safe for this particular rocket for the payload which it is carrying or not, what type of fuel it is carrying or not, and so on and so forth. So on the cloudy day it was done, and you will, if I scroll down, so there were 60 launches which were done, successful launch till the end of the data which we have over here. The end of the data is on the last data point which we have in this data set is not it's 2020 over there. 30th May 2020 was the last day when the crewed missions SpaceX Dragon was launched, and the SpaceX Dragon mission was pushed because of bad weather before that on 27th May, and then on 30th May it was finally launched. So you will notice that there are few that in this data set. See, the practical problem is from the point of view of a civilian, the practical problem is that we have the good data points like launch was done, but the reason why the launch is there must be a lot of dates which have been pushed, but because of various factors that data is not revealed by the space agencies throughout the world, that why that particular launch was cancelled, whether weather was involved over there, or what was the reason as such. So the data which we are using is not the data which NASA really will be having internally, because they will be having so many more data points and so many more factors, and they really the data of the bad days as well, or those scenarios where the launch was pushed. So one thing which we have done is to make a balanced data set, to be able to at least get started with something, the day before and the day after will be, the few days before and few days after will be considered as the days where the launch was decided not to be done, or the weather was not suitable. But it's not really true. The day before it, it's possible it was that may not have been the reason because of weather itself. But to make the data set, this bias has been added by the collector of the data to get it started, because the real data is not available. It will only be available to for NASA, to for will be available only internally available by, or will be there for the data scientists internally or SMEs inside NASA itself. So that one bias is there. So that thing, but there is no workaround for now, for from the point of view of civilians like us. Now, when we talk about the algorithm selection, so the problem statement which we are solving is, thus will the success be there or not? So this is Microsoft's Azure machine learning cheat sheet. You start from the middle over here, and then there are various sections like extract information, prediction between categories, prediction between two categories, classification of images, anomaly detection over there, prediction of some values, regression basically. So the problem statement which we have is like the days on which the weather will be suitable for the launch, or the push, the day the launch will not be pushed. So basically we are going for binary classification. So these are the binary classification algorithms: support vector machine, perceptron, forest, descent forest over there, regression, logistic regression. We are going for this one, two class boosted descent tree. You can try other algorithms as well. It just trains faster, is accurate, but it is having a large memory footprint. That's one of the downfall. So try other algorithms. Now the the normal machine learning process starts. The data which we have is not really clean. We have lots and lots of missing information. If you think about the sensors also, which are gathering the data from various sources, those sensors might not be operational on that day. So because of that, some data might not, that it may have missed few of the data points for that day, or that for the entire day itself. So there are a lot of issues in the data which we have to work with. and we can do the best which we can do. So we are doing the simple things first. We are importing pandas for tabular data, for NumPy for the mathematical operations. We are using scikit-learn for most of our work. We are doing the dysentery classifier is being used, and there are few of the columns which we are which are of more interest to us. Uh, and I'll correct my I'll and this is I'll correct myself. It was 64 launches were done, not 60. So it contains 64 crew or without crew rocket launches over there. And this is a few of the columns which are of more interest to us, where temperature, humidity, wind speed, direction, precipitation, visibility, sea pressure can be thought of. Now, this is the data which I was showing you earlier. I have it loaded over here. And if you see, there are a lot of NaN values, not a number over here. And then we have few of the values which I was showing you earlier. There are lots and lots of missing values in observations because of various reasons. And the data is not available for public. Whatever we have, that's the maximum we could gather. Rest is not available. Now, the columns, if you want to have a look at the columns, these are columns over here as such, but the more information will be available in the .info. You can see how many values are available and how many are null. So 60 non-null values are there, 300 non-null values. Few of the columns will be having all the null values. So there is no value in that particular column itself. It's totally empty. So we are not taking that forward uh, as such, and we will be dropping a lot of columns going ahead. So time, location, crew launch 60. The target for us is this, whether the launch was done or not. That's the target for us, 60 values are there. And the so some of the data cleaning approaches which we are taking is that we first of all the uh, so the in the launched in the target attribute itself, we have y's over there. Y's are the ones where the launch was done, like this y, and only one n is there when the data is publicly available. Why that the dragon's SpaceX Dragon launch was not, it didn't happen. It's publicly available. But why other why what was the reason behind other launches, for example these, why were they not why were they pushed, whether was the whether weather was the condition reason, or what was the other reason, that information is not there. So what one thing which we are doing is, this is the bias we are talking about, but one thing which we are doing is other values we are filling with n. No, we will consider that it was that weather was the reason why that day launch didn't happen. There is no other way around, right? Okay, so we'll take care of that, and we will also take care of the crews. They are missing values in the crews as well. So they are very less crewed. The missions were there where crew was there. So anything which doesn't have any value over there, we will just say, we'll assume that the crew was not involved, and there was no crew on the space shuttle over there. Then the missing wind is having issues. We'll take care of that. We'll the For the missing condition data, we'll assume that it was a typical day, and we'll put fair over there, like typical day. It's okay. And for any other data, we'll use 0. So we are doing it over here. So once we have replaced all the from the launched column, crewed, uncrewed, crew, wind direction, condition, fair, and so on and so forth, this is the final data set which we have received. And if we check the information for it, we don't have any null values over there. We have taken care of the missing data with us as part of the data manipulation steps, and all the observations have at least something over there. And which we are doing. Now we cannot, it will not be possible for us to work with any categories as such. Mathematics happens on numbers. You have to encode it in one way or another. So we are encoding them using the label encoder, and we will be putting, for example, we'll use 1 for when the crew was there, and 0 when the rocket didn't had any crew over there. So using these type of zeros and ones, we are finally taking care of that. So you will notice that after we have replaced all the text with on few of the attributes. We skipped few of them. You will notice that we have the values like 1, 0, and so on and so forth. Now, what else can be done? So we were just discussing about that this data is highly biased, but what else can be done? So there are few of the learning steps which Microsoft suggests that can be done by the learner over here uh, to make it even better. And I will just see if I can open Microsoft's learning link to read this, because it will be easier for us to read it over there. So I'm just going to the learn module link in my secondary page, and I'm just looking at it. Otherwise, we'll read it over here only. Okay, check this out. So these are the considerations which can be done uh, over there. So explore the data further. Look for article. How can you make even a better data set? This is where it is being open-ended. Like you are also involved, where you can further improve the data. So look for articles and reports on each launch, whether there were considerations made about the weather before the launch or not. Was NASA or any other space agency, were they worried about the data? Explore the missing weather data. Gather it from various locations as such. Explore the missing launch data. Uh, you can also make a data set where multiple countries, you can make a way cleaner data set, a way better data set by not just involving NASA. You can have ISRO, and you can have other countries space agencies as well, whose data might be available, and you can find the reasons why they pushed the launch on that date, and you can make even better uh, data. The one of the problem which we are facing over here in this example is you cannot see, there is no trial and error. You won't be able to when you if you think about space launch, the rocket launches, the you cannot try you cannot just if the weather is bad, you cannot just launch the rocket and see whether it will launch or whether it will be on trajectory or will be on trajectory, because that's neither ethical nor it's possible. There's so much of just for the James Webb telescope, it started years back, and so much of efforts and human resources and monetary resources are going in that. It's not the economics doesn't even work for it. You won't be able to support. So you can do simulations. So the best what you can do is you can do simulations, or you can gather data from maybe from other sources as well, which can represent your problem statement. So manipulate the data in better ways. Instead of you can impute it in better ways. You can evaluate similar problem statements. So you can find any other maybe airplane delays or any other similar type of delays to make the data set even better. So these are the few considerations to be followed for you guys. Now, the machine learning is very straightforward. We have the target attribute is the launched yes or no. We are dropping few of the unnecessary columns, name, date, and few of the columns which don't have or which have the same value, exactly same, and some other things. Uh, the classifier is a binary classifier decision tree over here. And we are splitting our data set into xtrain, xtest, ytrain, ytest. We'll do the training and testing. Test size is 20%. And XYZ is the split which we are doing. We are fitting the model over here, and we are doing the testing on the data over here. And we are using and on this data we are achieving pretty high accuracy, but as we already talked about, that this might be overfitting and this might be little biased towards this the data might be biased towards one of the class because of imbalance in the data set, but that's what we have. So the graph of the decision tree looks something like that. You can further have a look at it, evaluate it further. And the you can say that when we when and we can test it on some other data points as well. So this particular data was taken from one of the recent launches, and it was found that the model was predicting it properly, that the mission will not be successful or will be was pushed because of weather over there. So if I take you back to the learning module over here, there are, and just to close up on what we were discussing about, we there that's and we were just discussing about this as well a few minutes back, that it's that there are machine learning should always you should do your own you should put the ethics in place as such. And if you think about, there are a few examples which are given here. So just for your information, maybe you already are aware of it or not. So the conditions between the men and the heart attack symptoms and the conditions in which those symptoms are generated or when heart attack really happens is very different between men and women. So in the recent health studies, huge population of people were omitted from the initial data collection, and it affect the model of heart attack symptoms that are being used in the healthcare industry. So when they gathered the data, they they didn't, maybe they were not aware of it or something. And so you can imagine that the type of medicines which they are creating, targeting men versus women, is more generic versus what it should be, because men and women have different heart conditions, or there are different scenarios in which the heart conditions they occur. So this has been recently figured out. Similarly, definitely the data which are working with today versus the one which NASA will be using for their own astronauts uh, will be will be having a huge bias. But this is just to get you started, or for your to get the thought process started over there, where you will find that uh, what are the various other use cases for machine learning as such. And NASA will definitely, or any other space agency will make sure that the real life is never risked, or it's very unlikely that something will go wrong during those launches over there for that purpose. So this is what I had for the session. This is where we were thinking of the other use cases for machine learning, where we can use it for detecting the and the then the, and the, for the delays in the launches and the challenges which we face from the point of view of being a civilian and looking for the data. But there are other sources or other problem statements which are still interesting, and you can definitely stay motivated to learn machine learning on that. Please ask your questions. Go ahead. You can unmute and ask your questions as well. And the learning module link is in the chat. We will repaste it for you guys to go through it.
Sharing the link.
Right? Okay. Okay.
Any questions, guys?
The we'll put the learning module link. Parth, if you have it.
Yeah, I have.
Yeah. Okay. So guys, we do these type of sessions very often, where we do hardcore machine learning sessions also, and the ones which are slightly you can say different and more fun oriented. So this is that fun oriented session, and the learning module link is in the chat. The last link is there. You can join us on the meetup page, join us on the LinkedIn group. You can find me for your questions even afterwards, whenever you have any thoughts or doubts or questions as such, or you want to share something with me or with us. You can find us on LinkedIn as well. All the profile, all the links are there on the learning module. And right now you can unmute and ask your questions.
So Shivam, do you have any remote sensing data, like from the satellite captures data of the Earth, where we can predict the crops will be saved from the satellites, like the images of the crops, so that any rainy season or any dry season, you can just preserve the crops from any natural disasters.
Okay. I can check for the data. If you ping me on LinkedIn, I can check and let get back to you. But if I just want to show you something, I you randomly ask that. You see this background right now. This is called as
Yes, yes.
Azure Space. Azure Space is their this is a live feed which is coming from the space part of Microsoft's Azure Space. Their AI modules are right now running in the in space station, and I have it installed somehow. You can also look for it how to get it installed, Azure Space, and I will can change the feed. It's a live feed which updates every 30 minutes. So data will be available. We just need to look for it. I don't have it handy with me, but I can definitely look for it and get back to you.
Okay, actually last year I did a workshop with ISRO where they have remote sensing data of captured from the GLSLV satellites. So they were doing this kind of workshop where they were showing us how they're predicting the preserving the crops of Indian of Orissa, the main
Okay.
peninsula lane. So I was thinking whether NASA have this information where they have
Must
kept in
be
Microsoft.
definitely. They must be having it, and it will be available on the. I'll give you that link where their data set is available, and the link is going in the chat right now. The last one.
Excellent, buddy. Excellent. Okay. Okay, I'll check it out. I'll also do from my side. If I face any difficulty, maybe next session I'll ask you.
Sure, sure.
So any more questions? Let's end the session then.
Right. So, guys, then do find us for the next sessions as well, and you can definitely reach out to us over the social media. You can join us for over the meetup page and the LinkedIn page as well. The recordings will be uploaded on YouTube. So find our sessions, subscribe for the entire Reactor page, and have a nice day.
Thank you, Shivam.
Thanks, everyone. Take care. Bye.
Thank you, Shivam, for the session.
Thank you. Thanks
And
everyone.
thank you
Thank
all for joining us today. Please do share your
Which
feedback.
is the YouTube channel again? Which
Parth,
which
if
is the YouTube
you
channel?
The YouTube channel, I have sent you the link. Can you see the link?
check the last one, I
Uh,
just repasted his link.
yes, now I got it. Thank you.
Yeah.
Right.
Yeah.
Okay.
Okay. So guys, have a nice day. Parth, thank
Nice
you.
day. Yeah. Yeah.
Right. I'll see you in the next session. Bye bye.